All right, today we're going to focus on section 4.2 with the angles in a triangle. So the first thing that we're going to look at is a fact that you guys have probably known for a long time, and that is that the sum of the measures of the angles of a triangle is 180 degrees. All right, so if I add up those three angles in there, in this case, are x plus 50 plus 75. I know that I can set that equal to 180. In just a second, we'll prove that and give some justification for it. And so that would give us x plus 125 equals 180, and in this case, x equals, if I subtract that 125 over, 55. Now, one definition we'll need when we justify this is an auxiliary line. This is basically a line that you add to the diagram. Sometimes we'll choose for it to be parallel to another line. Other times we'll choose for it to bisect something. But it's something that we're putting into a diagram to help us justify some conclusion that we have. And it's a good way for us to sometimes work through proofs by adding things in. Place, if you remember that we did that before, was when we had two parallel lines. And then there were two lines. We were given a couple angles like this picture, like a 25 and a 50 there. And we drew in that auxiliary parallel line. All right, so we're going to do a very similar thing in this section. Now, example 3 gives basically two problems. So go ahead and stop the video, give those a shot. I'll give you a couple minutes, then restart the video when you're done, see if how it compares with what we have here. All right, so you're jumping back in the video, so you've already tried these two. In this first one, we're going to add this up, and I like to just kind of walk around the angles and add up like terms. So I've got 4x plus 4x, which is 8x. And then I've got 20 plus 16, which is 36, plus 32, which is 68. So I have 8x plus 68 equals 180. All right, we can subtract that off. 8x equals 112, and then we can divide both sides by 8. Now, as we go through, we can reduce that down and get to our x value there as needed. Sometimes the problems are a little sneakier, though, like the next one. In this next one, we have two parallel lines, here and here. All right, so I'm going to lean on alternate interior angles first, and I've got the 60 degrees up here. That also comes down here to 60 degrees. All right, I have vertical angles, so I can bring the 50 degree in here. Now, alternate interior angles, I also know that E is the same as that 4x, so we have those two congruent as well. So I'm going to lean on the angle sum theorem for a triangle, and I'm going to go ahead and add these three angles up. So I've got 4x plus 50 plus 60 equals 180. That's going to be 4x equals 180 minus 110, or 70, which we can divide both sides by 4. And we end up at a 35 halves. Okay. So that's going to be our x value, 35 halves. It asks us for the measure of angle C, that's 60. And then it also asks us for the measure of angle E. So if I take that 35 halves and I plug it back into 4x, right, then I'm going to be able to reduce, so the half and the 4 will cancel. So I've got 4 times 35 halves. I can reduce there. So it's 2 times 35, which is going to be 70. All right, so angle E is 70 here. And there's a lot of ways to get there, but that is, I think, the easiest route. All right, so now let's make a quick argument as to why the angles of a triangle have to add up to 180. So first thing we notice is we've got the triangle ABC that's drawn here. All right, and then we've labeled the angles 1, 2, and 3 going around. All right, and that's just for ease of notation a little bit later. So the first thing we're going to do is we're going to draw an auxiliary line, XY, which is this dashed line up at the top. And we're going to construct it specifically so that it's parallel to the side opposite B. All right, so we have parallel lines there. All right, so first thing we did is we constructed auxiliary line, XY, parallel to side AC. All right, so now we could say that angle 5 and angle 2 are congruent, all right, because we have alternate interior angles. We could also, with the same argument, say angle 1 is congruent to angle 4 because of alternate interior. Now, clearly, angles 4, angle 3, and angle 5, when put together, form a straight line, right, or a straight angle, which would be 180 degrees. So we're going to say that measure of angle 3 plus measure of angle 4 plus measure of angle 5 equals 180, all right, because again, they form a straight line, so we're going to have 180 degrees. We know that 4 is the same size as 1, so measure of angle 1, I'm going to do a substitution, all right, and then we're going to keep angle 3 as is, but we also know angle 5 is congruent to angle 2, so I'm going to put an angle 2 in there. All right, at that point, with just some substitutions, notice we have measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. So now we can say that the sum of the angles in a triangle is 180.